Okay, so we're talking about population ecology. I've already done a video on those graphs where you have the exponential growth curve and how to solve those problems. So now I want to talk about the logistic growth curve. So an animal like that is a case-selected species. They're usually larger. They have a type 1 survivorship curve. And this type of growth curve is called the S shape just because of the curve here. You can see the J shape is in the blue line here, but due to environmental resistance, the growth starts to slow down and they hover right here around the carrying capacity. When you want to calculate those problems, when you want to look at the change in population over time, you have to take into consideration how close they are to the carrying capacity. So let's take a look at that. One thing when you're doing your calculations, remember R is just the birth rate minus the death rate. That's usually a decimal number. N is your population size. Then your carrying capacity, let's say you had a carrying capacity of 100 for your particular population, and your population size is only at 10. Well, 100 minus 10 is 90 over the carrying capacity of 100. That would equal 0.9. So when you're really far away from your carrying capacity, the impact of this on R times N is going to be fairly minimal. It's just going to be closer to the number 1. But if you are very close to your carrying capacity, for instance, if your carrying capacity is 100 and your population size is at 90, now you're at 10 carrying capacity minus your population size over your carrying capacity of 100, you're now at 0.1. It's going to have a larger impact after you multiply R times N. So I want to give you a sample problem. Maybe you can screenshot it and then put the camera down put down your phone and try to work it out. If a population of dandelions is currently 40 individuals, so that's your population size N, and your R max, your R is 0.2 dandelions per month. Predict how many dandelions would be in a population the following month if the carrying capacity K is 70. Okay, spoiler alert, here it is. Okay, so what you're doing is you're going to take your R, 0.2, times your population, N of 40. Then you take your carrying capacity, 70 minus 40 over 70, multiply that together, and you're going to get 3.44, meaning your change in population over time is 3.44. Add that to your current population of 40, and you're at 43.